In question 3, essentially you've got two bags, bag P with 3 red balls and 3 yellow balls, and bag Q with 4 red balls and 3 yellow balls. You are then told that a ball is randomly selected from bag P and put in bag Q, and then a second ball is also chosen from bag P and put into bag Q. So let's try and make sense of what on earth is going on with this diagram here. So in the first instance then, we're looking here at bag P. So I know that I've got 6 balls in total, and I've got 3 red. So the probability of a red one here is going to be 3 over 6, which is a half. And then similarly, because we know that these two probabilities must add up to 1, this one must also be a half. So if we have gone down this track then, we know that our first ball selected was yellow. So when it comes to the second time we select a ball from bag P, there are only 5 balls left. So straight away we can we can put in the denominator is 5. If the first one is yellow and there were 3 reds initially, then there are still going to be 3 reds. So that should be 3 over 5. And similarly then here, if the first ball we selected was yellow, initially there were 3 yellows, and now there will therefore only be 2 yellows. So that was 1 mark then for getting 3/5 and 2/5. And similarly we can continue working out the rest of these branches here. So if my first ball was yellow and my second ball was red, well, in fact here, because we know that these two probabilities have to add up to 1, we don't even need to calculate the answer, other than saying that 1 take away 5/9 is 4 over 9. So that's just using the complement of event there. But in this branch down here, then we are going to have to figure out what's happening. So we've got a yellow ball first of all, and then let's suppose, so we've got 2 yellow balls. So remember, I take each of these balls from bag P and put them in bag Q. So if I started in bag Q, so there are 7 balls in total here, 3 of which are yellow. So if I've then drawn 2 more yellow balls and put them in here, there are now going to be 5 yellow balls out of 9. And again, similarly, we can work out through the complement event that this must be 4/9. Looking then at the top half of the branch, similarly, if the first 2 are red, then we can say that in bag Q, there were 4 red initially, so we've got 2 more red balls going into that bag. So there will now be 6 over 9, which we can simplify to 2/3. And again, using the complement, we can say that that is going to be 1/3. In part B, we are asked to find the probability of the event A, and event A is defined as the 2 balls being drawn from bag P having the same colour. So there are 2 different ways that we can get this. We could get red and red, so we need to work out red and red, but we could also get yellow and yellow, so we therefore need to work out yellow and yellow. So again, remember that when we're going along the tree diagram, we're going to multiply the probabilities together. So red is going to be a half times 2/5, and we therefore need to add to that the probability of yellow, which is going to be a half times 2/5 as well. So we will end up then with an answer of 2/5. In part C, we are asked to show that the probability of event B is 5/9. And event B is the probability that the ball drawn from bag Q is red. So first of all, we need to identify all the outcomes in which the ball drawn in bag Q is red. So for instance, I've got this one, this one, this one, and this one. So if we take, for instance, the first one, to actually calculate this probability, I've got to go along the branches of the tree diagram, therefore I'm going to multiply. So the first one is going to be a half multiplied by 2/5 multiplied by 2/3. And in effect, what I've got to do then is work out each of these probabilities, these 4 probabilities, and add them together. And if I add that all up, I do indeed get an answer of 5/9. In part D, you are asked to show that PA intersection B is 2/9. So we are trying to show here then the probability of both A and B occurring. So that is the probability that both the balls selected from bag P are the same colour, and then in bag Q, red is chosen. So again, the first thing we need to do is identify the pathways which are valid. So having two the same colour, they could be red, red, and then I've got to select red in bag Q. So that's going to be this branch here. So I need to calculate this one, which is going to be red, 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 and then I also need to add the possibility of getting yellow in the first and yellow on the second and then red on the third. So that is going to be yellow, yellow, red. So the probabilities for that then is going to be a half times 2/5 times 2/3, and to that I'm going to add a half times 2/5 times 4/9, and if I do that, that will yield me the answer of 2/9. So if we have a look at the information that we've got so far, we've got PA is 2/5, we've got PB is 5/9, and PA intersection B is 2/9. It might come as no surprise, therefore, that in question E, where you are asked to find the probability of A union B, or probability of A or B, that we're actually going to be required to use all of this information, because here we are going to have to use the addition rule, which we can say is the probability of A plus the probability of B minus the probability of A intersection B. And if we substitute in our values for that, we are going to end up with a value for P A union B equal to 11/15. Part F then is where the fun begins, because you should recognise the code word at the very start of the sentence given as a clue that this question is all about the conditional probability, which is what we've got here. So we're asked to find the probability of getting red, 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 given that all 3 balls are the same colour. So we can recognise this is analogous to the general formula here, PA given B. So this is how we find the conditional probability for the probability of A given B, which is the probability of A intersection B over the probability of B. So if we try and interpret this equation in the context of this question, this is going to be the same as the probability of red, 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 and the same colour, all over the probability that they are the same colour. So the only way here, the probability of getting red, 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 and the same colour, we're looking at this branch here. This is the only way that we can have red, 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 and them all be the same colour. So our numerator, therefore, is going to be a half multiplied by 2/5 multiplied by 2/3, which is just going along here. Now, the denominator, we could work it out. The probability that they're the same, well, that's just going to be red, 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 or yellow, 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 which we have actually already worked out in an earlier part of the question. But just for completeness, we can see that it is going to be this. And if we add those two together, and then we divide our numerator by that value, we end up with a conditional probability of 6/11.